Unfortunately, I've lost the audio of this particular section of the video. I put a 7/8 Whitworth tap into the part I've just made, and I'm going to clean the threads up using the tap. Plenty of anchor lube. I've also got the tap supported on the lathe tailstock. I'll put the lathe into a low gear and then just turn it by hand, feeding the tap in using the tailstock handreel as it goes. The tap's done its job. As you can see, the nipple screws in nice and freely, which is exactly what I want. You can see in the back there, I'm going to have to machine some of those threads out and make an adapter to go in with a tapered seat so it will sit on the grease nipple. I did this because I didn't want to have to start screw cutting this thread into a blind hole. So we'll put it back on the chuck, turn some threads out of it, and then make a seat to go into there, which will probably be welded in. Now we're machining the threads out of the back of the fitting. I've measured it, I need 14mm of thread taken out. In hindsight, I could have made the part with just the front ½ inch or so screw cut and threaded, but it's not a problem to do it this way. This material is cutting very freely. I was talking to a lad at an engineering company this morning where I actually got the bar ends from, and the black colour donates leaded steel. So it's got lead in, that's why it machines quite nicely. Now we're going to screw the nipple into the thread. As you can see, the tapered seat, that's the actual convex shape, so I'm going to make a concave seat to go into there so it seals and allows the grease to go through the nipple. I'm just going to use a piece of the same material to make the little insert out of. As I said previously, this is actually leaded steel. It's 4% lead, but it is machining very freely. I'm really happy with these lathe tools. That one actually wants the tip changing, it's starting to get blunt. You can see the way it's cutting, but I did get 2 packets given in the fitting of this holder quite nicely. I will change the tool to get a decent finish on it once we get near the size. I've changed the tip, or at least I've turned it round, and you can see how much nicer it is machining. You don't get the finish on the leaded steel that you get on some of the high tensile and harder steels, but it is easy to machine. This cut should take it down to size. It should be a nice slip-on fit. It's actually the same size as the hole. That would be a really good shrink-on fit or a press-on fit. We'll take another very light cut, and hopefully that should be it. It's very strange doing a voiceover. I'm not used to it. I don't particularly like it. I prefer talking as I'm making the video. It's my fault that the battery went flat on the microphone, I suppose, so we can't make it better of it. At least I have got the visual part of the video to look at. So we're taking a very light cut here. Be 0.1 per side, if that. And hopefully now it'll be a nice slip-in fit. Perfect, just what I want. I'm going to drill this part 8mm. 8mm is the tapping drill for 8 BSPT, which is the thread that's on the short length of grease gun hose I've got to screw into here. Nice sharp drill, going through lovely. It does cut nice and free, this material. I'm using this countersink just to machine a seat in, a concave seat that will actually seal onto the grease nipple. These are cheap Banggood tools, but they cut really well. There's nothing much the matter with that. I'll try the nipple in, and it wants to go a little bit deeper. That's not quite good enough. I'll give it a little bit more. Right, try it again, that's much better. It's hitting a much broader seat now. That should seal with the grease, no problem at all. I've parted it off to length now. Parting tools all set square on centre height. It should cut this off, no problem at all. Just checking I've got plenty of depth, which I have. Bit of Martian snot just to help it on its way. As I've said before, this steel is really nice to machine, very free cutting. But the trouble is you can't get a very good surface finish on it. Or at least I can't. Possibly if I ran it faster and took a heavier cut, it may be a little bit better. The part going back in the chuck now. Face the end, put a nice little chamfer on it, and then tap it 8th BSP. .45° tool you can use for both facing and putting the chamfer on. Very versatile tool it is. Once again, really cheap, bang good tooling that just works. Be able to power the tap, there's no problem. I've got the tap held in a keyless chuck. Sometimes the keyless chucks don't get a good enough grip on the taps, but this is quite a fine thread, so it should go in no problem. Once again, a little bit of the green stuff. Scrolling in quite nicely. Just trying to turn, but it's doing alright. It's often when you try and reverse it out that these chucks slip. Normally I use a collet chuck, this is bad practice really. It's actually reversing out, not too bad. Quite happy with that. That's the flexible hose screwed into there. That drops into there. It's actually touching on the seat now, so I want that welding in around there, or brazing in, I'm not quite sure which. You can see what's made an actual two-part affair. That's it welded on, the blue colours, just the way it went when it cooled down. Put a tap back in there just to clean those threads up, and then we can screw the pipe on, and that's it done. You can see how it works. Goes into there, taper to taper, so that should work quite nicely. A bit of pipe tape on there should help with the seal. So it's ready now to go and grease a 100-year-old steam wagon. Another quite satisfying job. Annoying that I lost the audio on the second part, but I'm sure a voiceover will do the job. Once again, it's time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do. I'm getting sort of very near the 100,000. I think I need 400 more. I suppose it is possible before Christmas. We'll have to wait and see what happens.